EDX Core Pure, sequences in series 1, summing series, using the standard formula to find combined sums. We've previously looked at 3 standard formulae, and we can now use these to work out sums whose terms are related to these. For example, we can now find the sum of a term called r squared plus 3r plus 1 from r equals 1 to 50 using our standard formulae. So here, r squared plus 3r plus 1 is a 3 terms added together, and we're going to add together 50 sets of these 3 terms. So the neat way around this problem is to separate it into 3 distinct summations. So we've got the summation of terms called r squared from r equals 1 to 50, and we've got 3 times the summation of r from r equals 1 to 50, and we've got the summation of 1 starting at r equals 1 to r equals 50. Now, sigma r squared from 1 to 50, we can now quote our formula for that. So remember, that was n times n plus 1 times 2n plus 1 over 6. So that in this case would be 50 times 51 times 101 over 6. And now we've got the sum of r from 1 to 50. Remember, the formula was n times n plus 1 over 2. So that will be 50 times 51 over 2. And lastly, we've got the sum of a term called 1 from r equals 1 to 50. So that's like having 1 add 1 add 1 add 1 add 1 50 times. So 50 times 1, we'll end up with 50. We can now work these out. This one will be 42,925. This one is 3,825, and of course the 50 at the end. And when we add all that up, we get 46,800. As we can see there. So they're the formulae that I used, and you need to be aware of these formulae, either learning them or knowing whether they are in your formula book. So in this question, we're going to find the general expression for the sum of the first n terms of r squared plus 3r plus 1. So in the previous example, we did the first 50 terms. Now we need a more general approach, and we're going to add the first n terms together. So again, we can still break this up into 3 separate summations. So it's the sum of r squared from r equals 1 to n, 3 times the sum of r from 1 to n, and lastly the sum of 1 from r equals 1 to n. So now when we quote our formula, so the sum of r squared will be n plus 1, 2n plus 1 over 6. And now we've got 3 lots of the sum of r, and quoting our formula, that will be n plus 1 over 2, and the last one will be in effect 1 add 1 add 1 add 1, and there'll be n additions of 1, so 1 times n will be n. Neat way to deal with the addition of fractions like these is to pull out a common factor, and the nice common factor here would be n over 6. So if we take n over 6 out as a common factor, so that for the first term would leave an n plus 1, 2n plus 1. And if I'm taking out n over 6 for the second term, that will leave 9 lots of n plus 1. And again, if I'm taking out n over 6, that last term would become 6. So we've got n over 6. And then if we expand the brackets, we we're going to get 2n squared plus 3n plus 1 plus 9n plus 9 plus 6. And then collecting like terms, we get 2n squared plus 12n plus 16. We can now pull 2 out as a common factor from this bracket. The 2, the 12 and the 16, we can pull 2 out as a common factor. So that's 2n over 6 n squared plus 6n plus 8. And then the last step, we can cancel the 2 with a 6, and quick check of the square bracket reveals that it will indeed factorise. n plus 2 times n plus 4. Okay, so there's the full method, and again they're the formulae that we need to be aware of when we're dealing with these problems. So in our final example, what if we're looking at the sum of r squared minus 1, but we start at 10 to 40 instead of the usual 1 to 40. Again, we can separate this into two summations. So it's the sum of r squared, starting at 10, finishing at 40, minus the sum of 1, starting at 10, finishing at 40. So if we look at the sum of r squared first, we need the sum of the terms from 10 to 40. So the way we deal with that is we find the sum of r squared starting at 1 all the way up to 40, and then we take off the terms that we don't want to include, which is the sum of r squared up to 1 to 9. So that will leave the terms from 10 to 40. And likewise we can do a similar thing on the sum of 1. So we want the sum of 1 from 1 to 40, and the terms that we don't want is the sum of 1 from 1 up to 9. So start using our formula now. So the sum of r squared from 1 to 40 will be 40 times 41 times 81 over 6. Taking off the bit we don't want, which is the sum of r squared from 1 to 9. So that's 9 times 10 times 19 over 6. The sum of 1 from 1 to 40 is 40 lots of 1. And the bit we don't want, the sum of 1 from 1 to 9, is 9 lots of 1. So simplifying this down now, we get 22,140 minus 285 minus 31 at the end, which gives a summation of 21,824. And you can see the full method laid out there. So that's the end of this session on summing series.